तो temperature dependence of the rate of reaction, कि how temperature impact the speed of reaction. Usually we know if we increase the temperature, speed will increase. So temperature role in rate of reaction means how temperature affect the rate of reaction. NCRT mention the example of N2O5. If you take N2O5, it will convert into 2NO2 and half oxygen. This is the reaction. Okay. But you will see the difference. Example, if your temperature is 0 degree Celsius, then same reaction will take 10 days to complete the process. If you increase temperature 25 degrees Celsius, then it will take 5 hours. And if you increase temperature by 50 degrees Celsius, then it will take only 12 minutes. Nobody will ask you this data. It's just giving you example how temperature impact from 0 degree take this time and 50 degree take this time. And you can imagine now why we keep our food item in refrigerator. We understand there are the negative impact also, but one of the basic reason why it is kept in the refrigerator is to reduce the temperature, because mechanism any reaction will slow down too much. See, like just imagine room temperature. It was taking 5 hours to break down the N2O5. But at 0 degrees Celsius, we are taking 10 days. Same thing you are doing at the in case of refrigerator. If you take food that is spoiled or rancid in 5 hours, but at 0 degrees Celsius or at very low temperature, it will take 4 5 days. Make sense? That is the ultimate thing we are doing here. And based on this data, we come up with the conclusion that ki if you increase temperature by 10 degrees Celsius. Hello. हाँ संदीप, गुड मॉर्निंग. गुड मॉर्निंग. फ्री नहीं, अभी मैं क्लास ले रहा था. कल संडे को भी क्लास था, इसलिए हमारा बात नहीं हो पाया था. ठीक है. तो ये क्या बोलते हैं, आज है 19, कल 20 21. 21 या 22 तक मेरा कंप्लीट हो जाएगा, तो हम नेक्स्ट वीक में 2 क्लास रख लेंगे, एक संडे को एक वीक डेज पे. ठीक है. ठीक है, फिर तो हम फ्राइडे को और संडे को रख लेंगे क्लास. ठीक- हाँ. ठीक है, तो फ्राइडे और संडे को पक्का. ठीक है, फ्राइडे को सैटरडे को संडे को मॉर्निंग में रखते हैं. हाँ, फ्राइडे मॉर्निंग एंड क्या बोलते हैं, संडे मॉर्निंग 10 o'clock अप. ठीक है, कोई प्रॉब्लम तो नहीं. हाँ, मैं उनको एक बार अपडेट कर दूंगा और तुम भी कर देना. ओके. हाँ, फ्राइडे एंड संडे. ओके. हाँ, मुझे अगर कोई इश्यू हो तो मुझे कॉल कर देना. ओके. सारा, यू आर हैविंग नेटवर्क इश्यू.
No, sir, no.
Okay. So, based on this, one statement is extremely important. Not this key. If you increase temperature, if you increase temperature by 10 degrees Celsius, okay, then your rate constant K, rate constant K will become double, nearly double. Okay. And trust me, many people believe कि when we are increasing 10 degrees Celsius temperature, na, Our rate is increasing double. No, not rate. K value rate constant is increasing. Rate constant, not rate. No doubt, rate once rate constant become double, rate is also increasing. But here we are talking about rate constant. Only that confusion you can have. You will never miss this key. Increasing 10 degrees Celsius temperature, rate constant will become double, not rate. Okay. So there was a scientist named as Vantoff. Like if you consider the scientist Vantoff, he was the first one who explained the role of the temperature in a reaction. Okay, impact of the role of temperature was first given by the Vantoff, but proper proof, proper interpretation, physical justification was given by the Arrhenius. So Arrhenius was the guy who gave the proper justification, physical proof of the same reaction. Physical justification and proper interpretation was given by the Arrhenius. Okay. And what was the Arrhenius explanation? He said कि I am telling you the equation that will explain the role of temperature. And according to his equation, your rate constant, remember not rate, rate constant will become a e raised to power ea by rt. And you know about this, like you will never miss this. I know. This is one of the popular equation given by the Arrhenius. हेलो बहुत बढ़िया क्लास में बता रहा था देर की लगेगा 1-2 घंटा तो हाँ फिर 4 बजे लूंगा तो इतना कहा तो था कि तो 2 बजे तक आ जा फिर मैंने थोड़ा सा वक्त तो करना पड़ा कितने बजे लेकर जाएगा थोड़ा सा ठीक है फिर घंटा में लेकर मैं घंटा में खत्म कर देंगे उधर से चल पड़ा मैं बस में आ जाऊँ बस में आ जाऊँ ना तो गाड़ी ले जाओगा हाँ ठीक है बस में आ जाओ ठीक है ठीक मैं फोन कर दूंगा तो नहीं लिख लूंगा
हाँ सर।
यस प्रतिज्ञा
सर वो जो सैमसंग वाला है ना, वो मेरा वाला ठीक है।
क्यों
तो मेरे फोन में चार्ज नहीं है।
क्या
मेरे फोन में चार्ज नहीं है।
ओके ओके तो ना एम आई ऑडिबल
यस सर, गुड मॉर्निंग सर, आई एम सो सॉरी।
इट्स ओके इवन आई नीड टू अपडेट little bit early
Sir, I was
so
sleeping, so I wouldn't have seen even then.
yeah
I
I
sent what I did last night on in the group, sir.
huh. So we are doing what is the role of the temperature in any reaction and how speed of the reaction is impacted. We were
Yes, sir.
taking example that if you take 0 degree Celsius temperature for this reaction and to O5, this breakdown process will take 10 days at 0 degree Celsius and 50 degree Celsius, it will take only 12 minutes. That's how refrigerator work. When we reduce the temperature, it will slow down the chemical process where bacteria, fungus, all are acting. Okay? So the general rule is if you increase temperature by 10 degrees Celsius, speed rate constant will become almost double. One of the first person who said there is a role of the temperature in the reaction, but Arrhenius gave proper explanation And interpretation, that's why we use Arrhenius equation. K is equal to A E raised to power minus EA by RT. Okay. You
Yes,
all
sir.
know what is K in this case, Tohina?
Sir, rate constant.
Rate constant, not rate constant.
Yes, sir.
Jordan, what is A? It is known as frequency factor or Arrhenius factor or pre-exponential factor. हेलो. हाँ जी. बढ़िया. क्लास ले रहा था. हम्म. हाँ. कुछ जरूरी बात थी. चलो फिर मैं करता हूँ अगली बार. ठीक. Okay, so all have same, like, it is the same thing. If you say frequency factor or Arrhenius factor or pre-exponential factor, you are talking about A. Okay. Sarah, what is EA in this case?
Sir, activation energy.
Activation energy. Barinder, what is T in this case?
Temperature.
Temperature. So, as we can see in this equation, if you have activation energy for a given reaction, temperature is the main factor that is changing. All other are constant. Activation energy for a given reaction is constant. R value is fixed. Frequency factor or Arrhenius or pre-exponential factor are fixed for a given reaction. Okay, and you can note it down. It is specific for a particular reaction. Any doubt? What Arrhenius said according to this equation, he said कि if you take any example, NCRT mentioned this example कि if you take H2 react with I2, you know it will form 2HI. He said that there will be a formation of the intermediate, and this intermediate will be unstable. Same thing given in NCRT. Ki, example, you have hydrogen, hydrogen. When it react with the iodine, iodine, so what will happen? This hydrogen bond breakdown will start, and iodine formation will occur. According to Arrhenius, this unstable complex formation is compulsory when hydrogen and unstable intermediate. Okay. So according to Arrhenius, he said that unstable intermediate formation is necessary when hydrogen and iodine react with each other, and this have very short life. Ultimately, it will convert into the 2HI. Got it? It will form 2HI. How much energy is required to form this intermediate complex? Amount of energy required to form this unstable intermediate is known as activation energy. Okay, so activation energy is the energy which is required to form the unstable intermediate or intermediate in general. Got it? Same thing can be explained in the form of graph. Graph says that if you take the comparison potential energy and if you take this reaction progression, how reaction proceed. So what will happen? Example, you have a reactant here, R reactant. First reactant undergo the high energy state because we said it form intermediate and intermediate are unstable, and then it will form the stable product. Okay. So amount of energy required, you already did this in biomolecule chapter. The amount of energy required to form this intermediate, which is unstable, that's why high energy. This energy will be the activation energy. Activation energy. So if you see this activation energy from the reactant to the intermediate, Chandana, what are the factors that affect this enthalpy involved? The change in the enthalpy in this case will be delta H, change in enthalpy. It can be positive or negative, both are possible. Delta H, correct? So, Chandana, what is the factor that decide the final enthalpy of this reaction?
So gives free energy.
Yes, yeah, gives free energy or final enthalpy will depend on what? It will depend upon the nature of reactant and product. Depend upon the nature of reactant and product. It means depend, and this will decide whether your reaction is spontaneous or non-spontaneous. Example, if your delta H is negative, it is good. Reaction is giving you some energy, really good. So you will see this is exothermic reaction, and this exothermic reaction is spontaneous. If you take another condition, delta H is positive, it means you need to invest lot of energy in the reaction. You are not getting any energy. So this reaction is the endothermic reaction. And this such reaction are known as the non-spontaneous reaction. It's known as non-spontaneous reaction and spontaneous reaction. Any doubt, guys? And because we are done with the thermodynamic, Barinder, tell me what happened in the spontaneous reaction in delta G and delta S? What will be the value of delta G and delta S and delta H? These three values in thermodynamic.
So delta G will be negative.
Hmm.
SV 0
And delta H.
negative.
Pratika, is this correct? Okay. So delta G is negative, S positive, delta H negative. Why? Because you have this equation delta G is equal to delta H minus T delta S. If you have two values, then you can find out third value delta H using this equation. Okay, and out Pratigya. What will be the situation in non-spontaneous reaction? Pratigya. Ruhina. Non-spontaneous reaction.
Sir, I'm not sure.
Delta G, delta S, delta H. Sarah. I think when we will welcome Anvita with one question.
Good afternoon, sir. Sorry I got late.
Good afternoon, Anvita. We will welcome you with one question. For for non-spontaneous reaction, what will be delta G value, delta S, and delta H from thermodynamics?
Delta G is positive, I think,
Hmm.
and
Correct.
mm, delta H, uh, I don't remember. So I think it's both. I don't know. I'm not sure.
Delta S negative, and because these are the two situations, so it will be positive.
Acha.
Okay.
Okay. And
So
delta S is negative one. I always think.
delta S spontaneous reaction, which is a good reaction, will once you start, it will happen naturally. So you want to always see only spontaneous because non-spontaneous is exactly opposite to this. So what will happen in spontaneous? Delta G is negative. It means you want to get energy out of this. Delta G is net. What is the result? Delta S entropy. Delta H enthalpy. So enthalpy and entropy will decide your G value. If G value is negative, you will get some energy from the reaction. Example, you want to burn your coal, okay, or wood or some other material. You want to see how much energy it will produce and how long. So you want to see your delta G value in this reaction. So people feel these delta G things are boring. But trust me, when you are using petrol, diesel, kerosene, CNG, any other part, we want to see this delta G always. What is the net energy we are getting? Is it like we have to invest energy or we are getting energy from it? Make sense, guys? Whatever food you get, eat, and how much energy you are getting, how much energy you have to invest in the absorption is explained by these factor only delta H, delta G, and delta S. Make sense? Every single thing in the nature is linked with the delta G. Okay, so we know these are the factor which is important to tell you how it is reacting because you know all the molecule that are reacting with each other, they do not have exactly same energy, correct? They have different energy, same energy. Example, kinetic energy is not same. To explain how the material will behave, there were two scientists, Boltzmann and Maxwell. Boltzmann and Maxwell. These two people, these two people, because same name is given in your kinetic theory of gas, if you remember. Chandana, what is given in kinetic theory of gas? Boltzmann graph.
Sir, I don't remember.
Jordan,
I don't remember, sir.
Tara, I think you were not there at that moment. No, you were
sir.
not. Then Pratigya,
So what did you
Barinder,
ask?
what was Boltzmann graph in kinetic theory of gases?
Sir,
Any idea?
parabolic.
Parabolic.
Hmm.
Do you remember something related to this? RMS speed is maximum than average than mean. Was explained by this. How energy is changing. Yes or no? Yes or no, guys?
Yes, sir.
Yes, sir.
I will show you notes. That's the thing. If I don't correlate with the previous chapter, I can finish every chapter in 2 hours. But the thing is, when we are correlating with the other chapter, it is always interesting to see one. Second, you remember all the previous concept. If you don't do this, then you will forget most of the thing. Let me see. हाँ प्रतिज्ञा
हाँ सर, मेरा फोन में चार्ज नहीं है और वो फोन में कुछ इश्यू हो गया तो मैं विकास नहीं कर पाऊंगी।
ओके
सर अभी कितने बजे तक क्लास करेंगे आप?
अभी ये बस हाफ एन आवर मैक्सिमम
ओके सर, मैं रिकॉर्डिंग देख लूंगी।
ठीक है
थैंक यू।
ओके look at this guys, we did kinetic theory. Yes or no? Was it same curve? You were telling if you change the temperature, more number of molecule will have kinetic energy greater than the activation energy. And based on that, we did this topic. We did average, RMS, and most probable speed using the same formula. RAM. RMS is maximum, then average, then most probable. Actually, I explained this one day before, and then I told you I'll tell you in the next class. Yes or no? In doubt,
No, sir.
note it down. That's why I'm giving time. Done, guys?
Yes.
Yes.
Yes, sir.
Okay. So, more important is what are the x and y coordinate in this case? You will see what is the number of particles for given energy divided by the total number of particles have they that particular energy. Okay. Here you correlate with the kinetic energy. You know if you increase the temperature, more number of molecule will have higher kinetic energy. And in this case, tip will represent the most probable speed, most probable kinetic energy. Correct? Because here you have most probable speed. So it will have most probable kinetic energy. Any doubt, guys? Same thing is explained by the Boltzmann-Maxwell graph. If if
ਪ੍ਰਭਾਤ ਲੈਟਰਿੰਗ ਵਰ ਮਸਾਲਾ ਗੇੜ ਨਹੀਂ
uh,
ਪਾਣੀ 8 20 ਕਾ ਨਹੀਂ ਵੀ ਅਟਕ ਸਕਦਾ 24 ਕਾ ਵਾਲਾ ਨਹੀਂ ਵੀ ਚੂ ਸਕਦਾ
give me 1 minute, guys. Come to the point. So in this case, what will happen? Same thing. Ditto same thing. You have a molecule like this, and this is having some energy like this. Arre, like this. Okay, this is the normal graph. If example here you have temperature T. If you increase temperature by 10 degrees Celsius, you know more number of molecule will have higher energy. Okay, and you know that we want minimum like maximum number of particle to have the activation energy. And look at this. After activation energy, because molecule are beneficial for us, only those have energy equal to or more than activation energy. We are looking only for that, nothing else. Correct? So if you are considering this part, this was the real kinetic energy useful to us. And in second case, you can see kinetic energy overall is more. That's why speed will be more. That is the benefit of the Boltzmann Maxwell graph and explanation. Not only graph, he also explained really well ki how different molecule have energy which is responsible for your real work, real productivity. Any doubt, guys? Any doubt in the Maxwell graph? So this is the
So can you explain it again? I didn't understand.
yes, sure. Because this is physics and chemistry both. We want to see how many molecule are really useful for us that is converting your reactant into product. Okay. What is the actual number of the reactant that is responsible for the real product? It's same like I gave you example of a company. You have a big company, MNC. 10 lakh people are working in your company. How many are really productive more than the minimum criteria? So they are useful for your country, company. Because based on that, you will select you will keep them in the next year or you will terminate them depending upon your calculation. Correct?
Yes, sir.
So, what will you see? Example, in a given condition, they were doing some work, X amount of work. If you increase stress, here we are increasing temperature. If you increase stress in the company, how they will react and what will be their productivity. Based on that, you can calculate these people are useful for you in the long run. Correct?
Yes, sir.
If same here, if you increase stress and they are more productive, it means such people are useful for you. What is the meaning of this EA? Minimum criteria everybody is fulfilling. Example, you are increasing stress and you uh, set it deadline key. If in the stressful condition, people work minimum 8 hours every day, only those will be selected efficiently 8 hours. If anybody is doing even 7 hours, we will going to terminate that person. Exactly same thing is happening here. EA is the minimum criteria set activation energy because anybody who is not fulfilling the minimum criteria is not required because that molecule will not convert into product, means will not be really productive and useful for your company. Make sense?
Yes, sir.
Huh. So first situation was T temperature. You had some graph, but when you increase the temperature, what is the impact? Impact is more kinetic energy, more productivity, more product.
Yes, sir.
Understood, everybody? So, you know.
Yes, sir. Understood.
Hmm. So exactly same thing you have in kinetic theory of gas and here. But one thing for sure, whenever you calculate the probability, total probability of the collision and the product, it will be one all the time because maximum percentage is 100. So maximum probability is 100, not more than that. So total probability, total probability. What is the spelling of probability? Is one all the time. Okay, always. Because it's like, what is the maximum percentage? 100. Maximum 100 molecule can be productive, not more than that, whatever you do. Make sense, guys? Any doubt? Okay. So what is happening using this Boltzmann constant method? If you are increasing temperature, in that case, more number of molecule with maximum energy will also increase. Correct? And then your kinetic energy will also increase. If kinetic energy increase and if this is greater than, if this kinetic energy increase is greater than the activation energy, then you know you will have more product. Make sense? Any doubt? More temperature, more number of particles with higher energy, more kinetic energy, more product. Okay. So, Tuhina, what is Arrhenius equation?
So when you
Uh,
ask that, do you mean the exponential form or the other?
exponential form.
Um, Arrhenius equation is
This one.
yes, sir.
So, in this Arrhenius equation, what this E raised to power EART means? It simply means what is the number of
Exponential.
molecule that have energy equal to or greater than the activation energy. Got it? In this case, E raised to power minus EA by RT tell you the fraction of molecule have energy equal to or greater than the activation energy. Only those molecule will be useful for us, and we want to consider only such molecule. Make sense?
Yes, sir.
And we already know what is A. Sarah, what is A? Sarah, what is A?
Answer is pre-exponential factor,
Or
frequency factor, or Arrhenius factor.
yes. If you take log both side, then you know log K will be equal. No, natural log. Because we always take natural log, not log. If we take natural log both side, natural log K will be equal to minus EA by RT plus natural log A. Any doubt by using same equation? Any doubt? Jordan, tell me if you want to uh, make graph between the natural log K and 1 by T, how the graph will look like?
1 by t, no, sir. Shouldn't it be a downward slope?
Yes, it will be straight line,
Straight line downward slope.
and downward slope. Why?
I don't remember why, sir, but I remember the graph.
Minus
That's
sign,
all.
minus sign.
Oh, yes, minus sign.
In graph, you never need never need to remember your any of the thing. You just need to focus on the one thing y is equal to mx plus c. If you know this equation in your physics and math, that is done. Your y value is in this case natural log k. Your m value is minus ea by r. Your x value is 1 by t, and your c value is natural log a. So you know your slope is negative, that's why downward direction. That's the problem in NEET now. You know why people face more problem in physics in general or some physical chemistry? Because it is more about the logic rather than memorizing the fact. And same thing is happening here. Ki if you are not understanding the graph, it means you didn't give enough time to understand the graph. Because graph is always about understanding, not memorizing anything. And this is for everyone. if you are bad in graph, there are two reasons. You had bad teacher, like bad teacher in a way ki you were not focusing in the class. Okay. Or second reason, you are not giving enough time to the graph. That's the only two reasons. There is no possibility of third reason. Am I right for everyone?
Yes, sir.
Because if you are scared from the graph, you will not solve many graph. And you feel ki it is tough, so I will avoid it and I'll solve some other thing. Here natural log A because y intercept. What will be the slope value, Anvita? Yes or no?
Yes, sir.
Hmm. So if you have this equation, natural log K is equal to minus EA by RT plus natural log A. This is the equation why I am writing so many times. So it is a good revision for you. Uh, Write as much as you like it is possible. That's why I tell you ki whatever you are reading, if you are not reading by writing, this is the wrong method. Okay. So if you take two situations at a given one temperature, the natural log K1 value will be equal to minus EA by R T1 because for a given reaction, your uh, activation energy will be same. Correct? Activation energy will be same. So plus natural log A because even A value will be same. At T2 temperature, your rate constant will be different because it depend upon the temperature plus natural log A. This is equation 1 and equation 2. If you minus 1 from 2, can you say natural log K2 minus natural log K1 is equal to, which is minus, 1 is minus. So if 1 is minus, it will become plus. It will be like EA by R T1 minus EA by R T2. Tell me any doubt? Because whatever value you are taking minus 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 will become plus. Yes or no, guys? So according to the formula, natural log A by B will be equal to natural log A minus natural log B. So this thing will become natural log K2 by K1. Here EA by R will be common. It will be 1 by T1 minus 1 by T2. Natural log X is equal to 2.3 log X. So this will be log K2 by K1. 2.303 will go to other side. Tell me, guys, any doubt? Now we are doing very last topic and but important topic, effect of the catalyst and collision theory. So just give me 2 minutes, and but before giving 2 minutes, I'll give you question. So you will be involved for next 3 4 minutes. Question is that you have any reaction C2H5I. All these are the NCRT reaction question. C2H4 plus HI. Okay. At 600 Kelvin temperature, your K value will be 1.6 into 10 raised to power minus 5 per second. Okay. Remember, this is first order reaction. Okay. Activation energy is 209 kilojoule per mole. You have to calculate K value. Let's take this is K1. You have to calculate K2 value at 700 Kelvin. Okay. Do it and I'll be back in 2-3 minutes. Few minutes. What was your K2 value? Pratigya. Anyone? Chandana.
Yes, sir.
What was your K2 value?
Sir, I got
Low K2 value.
2.59 into 10 power 3 into 1.6 into 10 power minus 4.
What I can see in NCRT answer, it is given minus 2.197.
Sir, even I'm
Hmm.
getting around 2.59.
Then you have to put the value of this. Do you know like how to put this value of log? K1 value was 1.6 into 10 raised to power minus 5. So what will be the value of this? This will be minus 5 plus log 1.6 value. It will be around, I guess, 0.2 something. Correct? It will be minus 4.8. You did the same thing?
So first I calculated the RHS part and I shifted the log to the right side.
Hmm. But when you calculated the value, you got the same thing?
Yes, sir.
Huh. Where is Sarah?
Sorry, sir, the football.
I think so.
Okay,
Network issues.
okay. Toina, you finished this question?
No, sir, I went to eat, sir.
Okay. So, Chandana, yes, we were talking about this log. So, guys, all of you, when you are calculating this kind of value, I will write here in the side. How to calculate log 1.6 into 10 raised to power minus 5. Whatever is the power, it will come into the multiply. Here, power is minus 5. So, you will get minus 5 number. Further, you have to calculate what is the log of 1.6. I know log 2 value is 0.3. Log 2 value is 0.3. Then log 1.6 value must be maybe around zero point 0.2. So I am considering log 2 value is zero point 0.2. So what will be log 1.6 in 10 raised to minus 5 value? Minus 4.8. Does it make
So,
sense?
can I come back in 2 minutes?
Sure, Anvita. Any doubt?
No, sir.
So in NCRT this is given, but I guess if you do the approximate calculation, you will get around 2.2. Okay, you will get minus 2.2. What you need to understand in this case, whatever is the number, you will get almost same value. Sarah, am I audible?
Yes, sir.
Yeah. So let me know if you miss anything. I will explain because you will miss hardly few things, 1 or 2 minutes or 5 minutes. So I can cover it fast. Okay. So Sarah, we were doing this question. You were there
Yes,
until
sir,
I
I
wrote
was
this
there.
question. Okay. So we wrote this formula. I explained how to calculate log 1.6 into 10 raised to power minus 5 value. So in this case, whatever is your power will come into multiply. 10 raised to power minus 5 value will log 10 raised to power minus 5 value will be equal to minus 5. And we know log 2 value is approximately 0.3. Log 2 value is approximately 0.3. Then log 1.6 value will be around 0.2. Even I don't know, but it will be around this because you can't calculate the exact thing in your NEET exam. So value will be this, and if you put this value minus 4.8, you can get the value. It will be approximately log minus k2 value. What is my concern? Let me tell you. Whatever number you get in the beginning, this will be your power. Okay. Example. Jordan. This is the important concept. I'm not talking about this particular question, but in general concept. If you have log 10 raised to power 2, what will be the value?
2
Hmm?
only, sir.
If you take 10 log 10 raised to power 5, what will be the value?
5.
5. Anvita, if you take log 10 raised to power minus 2, what will be the value? Anvita, are you there? Bhartigya, are you there? Varindra, are you there?
So I'm back. I heard my name. What did you ask?
What will be the log 10 raised to power minus 2 value?
Was it 1 minus 1?
Minus 2. Whatever your power,
Oh yeah,
this
minus
will
2.
be the
Sorry.
number. 2 will become 2, 10 raised to power 5 become 5. This. Varinder, are you there? Varinder, they are not there. Pratigya and Varinder. Varinder, I think she is facing network issue. Sandana, what will be 10 raised to power minus 5 value?
Minus 5.
Minus 5. So you understood this. Now, in same way, if you take anti-log of this minus 2 value, what will be the value? If you take anti-log of this minus 2 value, then it should be 10 raised to power minus 2. Ulta. Make sense? If you take anti-log of minus 5 value, it will be 10 raised to power minus 5. Log 5, anti-log 5 value, 10 raised to power 5. Anti-log 2 value, 10 raised to power 2. Make sense, guys?
Yes, sir.
Anti-log, if we take 5, then value will be 10 raised to power 5. So in this case, if you consider this minus 2, so at least you know your answer of K2 value will be in the power of 10 raised to power minus 2. That's all. You can't calculate the exact, but you can calculate approximate in the powers, and NEET will always give you like that. So you are not just doing this question, you are understanding log. And with this, you can solve all the basic log formula. Ki log 10 value means 10 raised to power 1 value is 1. Log 10 raised to power 2 value will be 2. Whatever is the power will be in the number. 10 raised to power 8 will be 8. Okay. Same way, anti-log of 1 will be 10 raised to power 1. Anti-log of 2 will be 10 raised to power 2. Anti-log of minus 6 will be 10 raised to power minus 6. Make sense? We did some formula. Is natural log x is equal to 2.3 log x. Natural log x is equal to this. Then log a by b will be equal to log a minus log b. Tara, what will be log 4 value?
Not sure, sir.
So log 4 is almost equal to 0.6 something.
Makes sense?
Yes, yes.
So in a log 8 value,
Sir, it will be log 2 to power 3. So 3 times 3 log 9 means 0.9.
imagine if you want to calculate the log 3 value between 2 and 4, it will be approximately, even I don't know value. In between, if you take, it will be around 0.45. Correct? This only. If you calculate log 5 value, it may be properly around 0.7. Correct? Around 0.7. Let's see. So you don't need to remember all the value. Log 3 value. See, 0.47. Near to 0.45. Make sense? Make sense, guys? Any doubt? So this, you need only this level, and mostly in your NEET exam they will ask this value only, mostly. Log 3, this, and log 10 is most important. Even in the, when we were doing our first order reaction formula, Chandana, what is first order reaction formula? K value.
So K is equal to 2.303 divided by the log R naught by R.
Correct. So here you need log always, and you will calculate by this method only for first order. So Hina, what will be the zero order K value?
Yes, sir.
Correct.
Yes,
Here
sir.
you don't need. That's why this is what we will do throughout our journey. Not only a particular chapter, but even previous topic, whatever we have covered so far. Revision. Revision is the key. And this is how we do revision. Okay. So log part in this chapter is extremely important. And I covered important log. What, how you need to calculate. Anti-log, people feel difficulty. You can't calculate because it will take too much time. Just compare the power, because examiner will always give you approximately number. They will never give you like number like this 1.16 into 10 raised to power 4 and 1.27 into 10 raised to power 4 for anti-log. I'm talking about for anti-log. Correct? You will never get this thing. Never in need. And you will never see even in the previous year question any of the question is like that. Never. So don't worry. What is the exact value, but you need to know power. Number is equal to power, as simple as that. Okay. Understood, guys? Catalyst. We discuss impact of the temperature. Now we want to study what is the effect of the catalyst on rate of reaction. So what will be the impact? When you add catalyst in any reaction, it increase the rate of reaction without doing the any chemical change. It's like if you sit in a bus. Example, if you sit from the Bangalore, you sit in this bus from Bangalore and you go to Mysore. What bus is doing for you? You are going from Bangalore to Mysore, but bus remains same without doing any chemical change. What is the role of the bus? To reduce your journey. If you go by walk, you might need 10 hours, or let's take 15 hours, but bus will reduce same journey into 2 hours. So what is the role of bus? Kind of catalyst in your journey. Same catalyst will increase the speed of reaction but not doing any chemical change. You are not doing any change in the bus. It just you are using it for the transportation purpose until unless we damage the bus property. That is different thing. Correct. So you can understand from this what is the role of the catalyst. Increase speed of reaction without any chemical change.
പാസ്പോർട്ട് സൈസ് ഫോട്ടോ ഉണ്ടെങ്കിൽ ഒന്ന് വേഗം അയക്കാൻ പറഞ്ഞു.
Any doubt, guys? Anybody have doubt? Anvita,
No, sir.
can we use catalyst word if we are decreasing the speed of reaction without any chemical change?
No.
No. For that, we use the word inhibitor.
Yeah.
Inhibitor reduce. Hello. ना भाई 15 आधा घंटा लगा मैंने लगभग चलने में हाँ घर आधा घंटा पहुंचा तो है हाँ 1 घंटा लग जाएगा तो मैं क्यों चल रहा हूँ मैं घर जो है घर आया था फिर ठीक है घर आया था बाइक पे ठीक ठीक so inhibitor reduce the speed of reaction without any chemical change. So we don't use increase or decrease. No.
Sir,
Yes, Sarah.
I'll be back in 5 minutes, sir.
Sure. Okay. When any catalyst is acting and increasing the speed of reaction, when any catalyst is acting and increasing the speed of reaction, it always acts by the intermediate complex theory. Chandana, what is intermediate complex theory? Is Brinder still there? Brinder, are you there? No. Okay. Chandana, what is this intermediate complex theory?
So,
Huh.
so
Before
product formed between the reaction and reactant
you know
product.
reaction convert into product, before forming the actual product, some complex will form in between reactant and product, that is intermediate complex. And this intermediate complex is having transition state only for the very short interval, and ultimately it will give rise the product. Huh. Hmm. What is the role, Jordan, of this catalyst? H- How it act? What is the important impact of this?
So the catalyst lowers the, how to this
What?
act it lowers the activation energy, therefore promoting faster reaction.
Yes. हाँ जी, लाइट आ रही थी वहां। फिर गलत सामान भी ले आइयो और बता दी मतलब कितने बन गए। या तो ले आइयो क्योंकि मैं जा नहीं सकता, फिर पहले रिक्वेस्ट है। ठीक है, बता किस टाइम से आओगे फिर। सामने लाइट आन दे। ठीक है, या तो ले आइयो फिर सामान। हम्म। इ- सामने, so it will reduce the activation energy catalyst, and when it reduce the activation energy, it will also reduce potential energy, because in your graph you have potential energy word, so meaning is same, energy will reduce. If potential energy is reduced, then reaction will be faster. Any doubt, guys?
No, sir.
Impact of catalyst. What are the factors that change due to the presence of catalyst and what remain constant? Sarah, are you there? She is not. Okay, Tuhina. So what will be the impact of catalyst on the Gibbs free energy? Tuhina, impact of catalyst on Gibbs free energy. Tuhina, are you there? Tuhina. Oh, she's not there.
So till what time will you take the class?
Next 15-20 minutes. Hello, Barinder. बरिंदर, तुम क्लास में हो, आवाज नहीं आ रही। मैं 2-3 बार बुलाया था तो इसलिए। क्या हो गया?
Sir, can you hear me?
हाँ Tuhina.
Hello.
Hello, hello.
Hello, sir.
Yeah, you are audible.
Yes, sir. Sir, my warden just called me and told me to call my class teacher. There's something about
Okay,
my JE, like the transportation. I'm writing it here, so they told me to call about the transportation. Can I come join back in a minute?
okay, sure.
Sorry, sir.
But be in meeting.
Sir, I don't know if I can place a call. I'll try, sir.
Okay, sure. हाँ बरिंदर, मीट। अच्छा, तो मतलब तुम्हें सुनाई दे रहा है अच्छे से? ठीक है, फिर तो मतलब तुम्हें पता चला ना 2-3 बार कि मैंने क्वेश्चन पूछा था। ठीक है। So I asked question from the Tuina. Sarah, are you there?
Yes, sir.
So what will be impact of catalyst on delta G?
Delta G.
It will remain same, because same amount of energy will be released if you make the diagram, and this is important for our biomolecule chapter also. Ki what is happening if you take this reactant and it form product? This is our reactant, this is product. This will be the delta H, which is responsible for Gibbs free energy. If you use catalyst will reduce your activation energy, but product and reactant energy is same. So delta H value will still remain same. Make sense? Only activation energy will reduce. Any doubt?
No, sir.
Huh. Second, Jordan, what kind of reaction it will catalyze? Spontaneous or non-spontaneous?
Uh, both no, sir. I mean, spontaneous, huh, mostly.
Because spontaneous reaction are more reaction that can easily
More
proceed,
reactive, yes, sir.
right? So spontaneous reaction. Does it catalyze non-spontaneous reaction?
No.
No, do not catalyze non-spontaneous reaction because I have seen many PYQ on these topic and many people ignore this kind of topic. They know zero order, first order basically, and many other things, Arrhenius equation because these are popular reaction. But in NEET, they miss like these important factor like what is the impact of this. Anvita, does catalyst change equilibrium constant?
Yes,
It does not change equilibrium constant. It will remain same. It
how
just make the process fast, but overall equilibrium will remain same. It will not proceed reaction in the forward or backward direction. Reaction will
forward.
remain same, just attain fast.
Got it.
Correct. So it just attain equilibrium faster, but equilibrium constant value will remain same in forward and backward reaction. So these all factors are extremely important. What is the impact of catalyst on a given reaction? Any doubt? And last topic of this chapter is collision theory. Barinder, what is collision theory? Barinder. Sometimes I feel like there are few scientists' names that are usually ignored by many teachers. Example, Chandana. Did you read like who explained this collision theory in detail,
No,
or it
sir.
was, or it was like you were not really bothered about the scientist name in collision theory?
No, sir. I never heard this name.
You never heard this name taught and William Lewis.
Yeah, I know Lewis, but I I
You
don't
didn't
know.
read properly like many times. This is like what happened ki, because in our exams scientist name are not usually asked much, so we don't read, but actually we should know, not like proper, what should I say, spelling, but just ki, okay, you have some idea collision theory is given by this, because in biology we read a lot, because we know in biology they will ask directly but not in the chemistry. Okay, so in this case we talk about the what is the minimum energy if two reactant molecule collide and form product, because what is the meaning of collision theory? A reactant collide, and when these reactant collide they will form product. Make sense? Reactant will collide and they will form product. That's the thing. And this is based on the kinetic theory of gas. Why? Because we have gas particle or like any reactant molecule, they collide. So they are moving. Moving means kinetic theory. Correct. In this case, whenever you take any reactant molecule, and this is also one of the drawback, if we assume these reactant molecule are hard sphere, we assume reactant molecule are hard sphere. Okay. So when these reactant molecule react with each other, you need two important factors. One is the minimum kinetic energy, and second is the proper orientation. Two factors responsible for effective collision will be one, minimum kinetic energy or minimum energy. Because if particles do not have enough energy or energy is less than activation energy, then collision cannot happen. Second, very important is proper orientation. Correct. So these two are really, really, really important factor that will decide how effective the collision is. Example, if you are talking about the activation energy, if imagine you are talking to someone, business meeting, if your energy is low, then you know your communication will not be effective. Okay, just consider instead of effective collision, effective communication. Two things: your energy level and your orientation, your probably dressing sense, more than dressing sense, like how you behave. Example, you were supposed to shake your hand with the next person, but you are shaking your like leg. You can take consideration. So it is bad behavior. Nobody will consider this, right? So proper orientation is extremely important and activation energy. These are the two important factors that will decide whether a collision will be effective or not. Any doubt, guys? This is extremely important, basic thing, but really, really, really important. Any doubt in this? Any doubt, guys, in this?
No,
Next is collision frequency. And as the name suggests, how many collision are happening per unit time. Correct? Frequency means per unit time. And this definition is also important. How many collision occur per second per unit time? Collision per second. But here also we are considering per unit volume. What is the volume? Because in case of gas, volume is really, really important. Okay. Example. If you take A react with B and it forms C. In this case, if you want to write rate of the reaction, it will be collision frequency of AB and e raised to power minus EA by RT, because you know activation energy is really important. Correct? Does it look very close to the Arrhenius equation? Because in Arrhenius equation, we had K was equal to A e raised to power EA by RT. Any doubt?
So I'll have to leave now, sir.
What happened?
So I have to go to the dentist office at 1:45. My uncle just now called me.
Sure.
Okay, thank you, sir.
Okay. Any doubt, guys, in these two equations? Any doubt? And based on these two formula, Arrhenius equation and your collision theory, that this Z is correlated with the A. Makes sense because both look very close to each other. In Arrhenius equation, you have A, and in if collision theory, you have Z, and both look very similar to each other. Correct. So, Sarah, what is this Z meaning is? like in simplest way, what is Z? We wrote this ZAB. What does it mean? In the literal way, it is the collision frequency. But what is the simplest layman meaning? Is Sarah, are you there?
Yes, sir.
So collision frequency simplest meaning is how A and B are colliding with each other and responsible for the product. If number of collision is less between A and B, then it will not form C. Make sense? Okay. And when we use collision theory, collision frequency between A and B. So when we consider here in this collision theory is applicable for the elementary reaction or simple reaction. Collision theory is applicable for elementary reaction. But if you see the complex reaction, then you will see a lot of deviation. This is not applicable. That is what I am trying to convey. Key collision theory is applicable in case of the elementary reaction, but not in the complex reaction because their way of dealing is different. And second, in this complex reaction or any other reaction, all collision do not lead to the product formation. All collision do not lead to the product formation. If your orientation is wrong, then there will not be effective product. Orientation is extremely important. Sometimes for the effective collision, you also consider one factor that is known as probability factor or steric factor. Probability or steric factor. This this probability factor or steric factor is telling you how effective the collision is. And that's why in reality, when you calculate rate, along with your Z, you will also add P. Correct? And with the help of P, you will get idea is there proper orientation of the molecule? Because everything else is same. You are introducing one more factor, P, probability factor or steric factor. And what is the role? It is telling orientation. Is it effective or not? Any doubt, guys? And so two things are important in collision theory. One is your activation energy, minimum energy with which two molecules will collide. If there is no minimum energy, it will not collide. And second is the proper orientation. It's like in marriage. If you take the example of the marriage, activation energy means minimum age. Minimum age is important. Example 21. Or in metropolitan cities, it is usually you can consider by not by law but by nature ki 25 or 30 plus. It's very common. Correct? So this is activation energy for the marriage. Effective collision. Second, proper orientation. Like proper gender should be there to have marriage. Correct? So same thing. So we are considering different things when how two reactant molecule collide and form the product. If orientation is not proper, they will not collide. Understood? And chapter is done. Any doubt, guys? And you can call this as the modified Arrhenius equation. So, how would you rate this chapter? Easy, medium, or tough? Let me see how many of you are there. Anvita,
So it's fine until the log part, anti-log part comes.
okay. Barinder, Barinder, you are not audible. You can write. Chandana,
Yes, sir, it is easy, but I have to revise properly.
okay. Sara,
Medium.
medium. Tuhina,
Sir, it's okay only.
it's okay.
Yeah, but I just have a little bit trouble with the graphs.
Graph. Let's see what I will ask same thing after 15 minutes. Not 15, 5, 10 minutes. Okay. First, in this chapter, you have rate. And if you see reactant convert into product, then in this case, reactant value will decrease. That's why negative sign. And product value increase. That's why positive sign. Okay. Second, if you see how this rate react in the rate law, you will see if you have x number of R molecule in the rate law, it says that rate will be equal to the rate constant and your reactant raised to power your coefficient. But it may or may not be equal to the x. That's why I will write some different number a, because it a could be equal to x or a might not be equal to x, but a can never be greater than x. Okay, rate law based on the what is the number of a. Example, if you take xr and yb is producing product, so in this case you know rate will be equal to r raised to power a and b raised to power, you can take any number, random number, q. Okay, so if you want to calculate what is the order of the reaction, order of the reaction will be their power. Order of the reaction will be the power. If you see the molecularity of the reaction, molecularity is the fixed number, usually 1 or 2, not more than 3. Not more than 3, and only for the elementary reaction, more simple reaction. Okay. If you see the zero order reaction, example how ammonia react in presence of platinum. So platinum play important role in this case and temperature. If you see here, you calculate the K value, it will be R naught minus R divided by time. Based on this, you can calculate half lifetime. Half lifetime is the time where your final value become half of the initial value. In this situation, if you calculate here, what will be the half lifetime? Instead of R, you will have R naught by 2, 1 minus half. Any doubt? So this is zero order reaction. If you consider the first order reaction, so first order means it depends upon the one reactant. Correct? If you calculate K value in this case, it is 2.3 by time log R naught minus R. If you see half lifetime, same rule. In half lifetime, your R value will become equal to R naught by 2. So your half lifetime will be equal to zero point 0.7 by K. It does not depend upon the R value, R naught value. Okay. Almost related to this, you have pseudo first order reaction, which look like second. In reality, it is second, but behave like first. And here you take example of ethyl acetate and cane sugar. Correct. After that, if you see the role of the temperature, if you increase temperature by 10 degrees Celsius, your K value become double. Okay. If you calculate your Arrhenius equation, EA by RT. Okay. If you take a ratio in the log form, so natural log K will be equal to minus EA by RT plus natural log A. Based on this, you can compare two different value in the form of log. It will be equal to EA by 2.3 R 1 by T1 minus 1 by T2. Correct. If based on this you calculate your values, you have catalysts that increase the speed of reaction, but delta G will remain same and equilibrium remains same, but it will reduce activation energy. It will reduce activation energy. And last, in the collision theory, you have two important things. He for collision there should be minimum energy, activation energy, and proper orientation. Proper orientation. Correct. And that's why you come up with the concept of ZAB, collision frequency. How two reactant molecule interact with each other or different molecule and responsible for the collision. And you have P probability factor. What is the probability of collision or steric factor? By using this, you can modify the Arrhenius equation where you add this minus EA by RT. Any doubt, guys? Not K, it will be rate. Tell me, guys, did I miss anything important and how much time I took to revise the full chapter? Guys, how much time I took to finish this topic?
It's a 5-6 minutes.
Yes. So though I tell same thing every time, revision always take minimum time if you revise the chapter properly. See, even I had this statement, like I had given this statement ki I will finish portion by 20th, but still I am taking more time because it's okay if we extend the date, but it's not okay if I do hurry and I try to finish portion without making it like correct. Now,
Yes.
can you revise the full chapter? If I took 5 minutes, within 15 minutes, you can easily revise the full chapter. Yes, you can. Right? You can in 15 minutes. But these 15 minutes are possible when you have proper understanding. Example, I missed this part. If you are taking gases 2.303 time log your initial value pressure is this, and what is the final pressure? Double of this amount minus total pressure. This was also modified form. So if I took 5 minutes, you will take maximum 15 minutes. This is how you need to revise in the end. That's why if I want to finish the portion, na, I can do in the same manner. Yeah, I will just write the formulas and done. That's the reason I always tell you, mind map never work. Never. Until unless you are extremely good in, in the chapter. Okay. So now I want to ask same question. Anvita, how is this chapter? Is it easy, medium, or tough?
Sir, I think it's easy.
Easy. Barinder Kaur, you must have wrote Barinder. Easy, medium, tough. Easy. And trust me, you will not get question out of this theory. This theory is enough. But theory is enough only when you revise it properly. Next, Chandana.
Yes, it is easy.
It is easy. Sarah Anthony. Sarah.
So between medium and easy.
Just in 5 minutes, you changed your statement. And I'm happy with it. Tuhina.
Easy only, sir.
Okay. So let's do a few questions and then we'll end this session. Now we can solve any question. So next is your chemical kinetic. We did this. We did this. Did this. Yes. See, you are having graph. Let me. Am I recording this session? Yes. Mm, 3, 4. So plot the natural log K versus 1 by T. We did this using Arrhenius equation. Natural log K is equal to minus EA by RT. Natural log A. Okay. So natural log K is equal to EA by R 1 by T plus natural log A. Okay. So in this situation, natural log K and 1 by T are directly related, but there is minus sign. Correct? There is minus sign. So how will be the graph, Chandana?
So downward slope, straight line.
Okay. So what will be y-intercept, Anvita? Anvita, what will be the y-intercept in this case? Natural log A. This is C.
Yes, sir.
What will be the slope? Tuhina. What will be slope in this case?
So, uh,
Minus EA by R. Graph will be between natural log K and 1 by T. Yes or no?
yes, sir, yes, sir.
Now, if you know all these things, you don't need to be bothered about how is the graph given. See? Correct? Yes or no? And see, we did same thing. And it's not like when we did same thing, it's like even I taught this. It is given in NCRT. See? Same graph. Correct? Same graph, same slope, same natural log A, and same nature of the graph. Yes or no, guys?
Yes, sir.
So this is done. See, they are giving the exact log value. Why? Because they know कि you can't remember the exact value. R value is also given. You have to calculate rate constant. No, rate constant and temperature is given. You have to calculate activation energy. Do it. Do it. Okay. So put the value and log K2 value is 14 divided by 4, 7 by 2. You can calculate the approximate value by using this. You can take other side all the values. 1 by 2, 8.3 divide by 2, 3500. What will be the approximate value? 4 to the 8, around 7000. Do you have any near? You don't have this value? Check it again. What mistake I did? Let me check. Log. It will be 3.5 only because. Oh, multiply by 2.3, na? Yeah. So this will be log 3.5 EA 2.3 multiply by 8.3. This will be 700 minus 500, 200 divided by 500. This, okay. So it was 2 by 3500. So whatever value you get around 7000, you will multiply by 2.3. That was your answer done. Yes or no, guys? We forgot to mention this 2.3 because we are converting natural log into log. Yes or no? And when if you feel you take stress, what how to calculate log value? Examiner is giving you already the values, so that is good thing for you. Anvita, this question: activation energy of any chemical reaction can be calculated if we know the value of.
The last one.
Last one. Yes. If you know the rate constant of two different temperature, at T1, what is your K1 and what is at T2, what is your K2? Correct. Same question. Tuhina.
So let me just check.
Answer will be D. Same
Yes, sir.
repeated question in 24 and repeated 24. Guys,
Yes,
solve
sir.
this
But
question.
sir,
Yes.
if it's just K, what will the graph be? Will it be like a parabola?
No, it will be same only, but it will deviate slightly. If
Huh?
you take K and temperature relation, then it will be parabola. Here we are asking 1 by T. If you take only K, value will be slightly different, but path will be same, na? But if you instead of 1 by T, you take T, then it will be different. It will
So
be,
can you repeat?
I am saying instead of 1 by T, if you take temperature, then it will be parabola.
Okay.
Because now it is inversely proportional, then it will be directly proportional, then it will be like this, minus. Got it?
Yes, I got it.
Sarah, this question. 300, and what is this? This is 300 Kelvin. This is 330. Your log value is also given. You have to calculate activation energy. Ditto same question. Ditto same question. And remember, your rate of the reaction become 4 times when temperature change. It is saying rate is quadruple. Quadruple means K2 value is 4 times of K1 value. You take LCM L1, L2, 300, 330. 330 minus 300 will be 30. It will be 10. Log 2 value is 0.6. This is your answer. Correct. You will calculate in the number. So, kilojoule. So you can eliminate 30, like 3.3. 3.3, 2 and half. What will be the answer? Will it be A, guys? Tara?
Yes, yes.
You don't need
Okay.
to calculate. You how I did. Key 8 3s are 24. 24 2s are 48. Almost half. 24. What is the nearest to 24? Done. Don't do calculation. Understood. Done. Same
Yes, sir.
question. Repeated question. See, your graph is repeated. Your activation energy is also repeated. Next, who is left? Chandana. A reaction can have zero activation energy.
No, sir.
Reason? Minimum extra amount of energy absorbed by the reactant molecule so that energy become equal to the threshold value is the activation energy.
Assertion is false.
Assertion is false. Reason?
Yes, the definition of activation energy is true.
Activation energy definition is true and assertion is false. Correct? Done. Because whenever some reactant convert into product, you need minimum energy. Some energy is required. Done. Let's do last question. Barinder, uh, can you speak? Barinder, can you speak? Yes, Barinder, this question. Yes, Barinder. Enthalpy of reaction is this. Activation energy this. What is the potential energy profile in this case? A, B, C or D? Can I? Huh. Barinder, she can speak to Hina.
Yes, sir.
Enthalpy of reaction is this. Activation energy this. What will the potential energy profile?
For
See, in first case, your enthalpy is positive because more. B is more than A, so it is positive. In second case, B is less than A, so it will be negative, and overall it is given negative.
okay. Okay, sir.
In C, delta H
Is the
is
same.
0. There is no difference.
Yes, sir.
And fourth, it is positive again. But in this question, they are asking about the negative. You have only one negative option. Done.
Yes, sir.
Done. And even in our notes, we discussed the same thing. Let me show you. Spontaneous reaction. See, delta H here it was negative. Correct? Any doubt, guys? Correct. If it is up, then it will be positive. Did I explain this also? I still remember somewhere in the graph I made this. I don't know where. In biomolecule, I think we did this. If not here, then biomolecule. Delta H here it is positive. Okay. So, based on all the question we did so far, can you see that this chapter is not difficult at all and they need never ask very difficult question? Yes, guys? Yes or no? Sir, chemical kinetic. So it's okay if we are extending the date of finishing full syllabus, but still we'll make it fast. Okay, but we'll do it properly so you don't feel key any of the chapter key. It will difficult. Example, optics. Optics, you will feel easy in the chapter but difficulty in the questions. Am I right?
Yes, sir.
So we can't make it fast at any cost. In EM wave, you will always feel that this chapter theory and numerical both are easy. You can easily solve. Am I right?
Yes, sir.
Yes. So that's the point. In some chapter you always face difficulty, especially in the numerical, and there are other chapters that are very easy. So I can easily finish the full EM wave in 2 hours with all the questions, not one or two or 10 questions, everything in 2 hours. But in optics, I need 2 days proper classes in case of optics. Modern physics was easy, but if you say rotation motion, again we need to solve question. We did properly rotation motion and we'll do it again properly with more questions. Understood? So don't hesitate. Whatever you missed out so far or you are not good in, we will revise those topics, but with full syllabus tests only. Yeah, I'll do full syllabus test. Other than that, I will take one by one. Example, there is Parthigya, Anvita, Barinder, Chandana, Sara, Jordan, Tuhina, Sania. So I will ask everybody, okay, what are your doubt topic or weak chapter, weak topic? So every day I'll take one person doubt like that. Okay. And question you can always keep. So we'll do in the end once we finish this. Okay, we'll make it soon. And once we'll finish the full physics and chemistry, you will have full syllabus test and biology parallel. Okay, we will do complete biology. Don't worry. Sarah, are you bothered about the board now? A little bit.